17. Here we have a 1.2 kilogram head of hammer, which has a speed of 7.5 meters per second just before it strikes the nail and comes to a rest. We are to estimate the temperature rise of a 14-gram iron nail generated by 10 such hammer blows done in quick succession, right? And we are going to assume the nail absorbs all the energy. So what happens here is that there's some kinetic energy in this hammer just before it strikes the nail, and after it strikes it 10 times, it always comes to a rest. So all of this kinetic energy just gets converted into heat. And this heat, of course, is just absorbed by the nail, and we are to find, so most of this heat, some of it is just generated by this collision, and some of it is just generated by the friction between the wood and the nail. And this heat is, we are going to assume, absorbed by the nail completely. So if we calculate the amount of energy and use the specific heat formula, then we can calculate the temperature rise. Right? So let's try and do this. So this is problem 17. Okay. So the change in energy is just the change in kinetic energy times number of blows. Right. So in this case, we just strike this 10 times, so it's 10 times the kinetic energy in one strike. So this is going to be just number of blows, let's say, times a half m hammer, right? So we are looking at the kinetic energy of the hammer, not the kinetic energy of the nail, which is of course 0, times velocity of the hammer squared, right? And this is going to be equal to C times m times delta T, right? The specific heat of the iron nail, or iron, the mass of the iron nail, times delta T. So this is equal to C times mass nail times delta T. So this means that delta T is just going to be number of blows times m hammer, square hammer, by twice the heat capacity of specific heat of iron times mass of the nail, right? And you just plug numbers in and see what kind of temperature increase you get. This is something that really happens. There should be some temperature increase, but it shouldn't be too high, it shouldn't be too low. This should be something definitely noticeable, but at the same time, it shouldn't be something like hundreds of degrees of Celsius, right? So you should get something reasonable at the end of this. So for this, you need to obviously look this up, and that is actually given in the book. Okay.